Hello and welcome to this brief demonstration of virtual energy management, or VEM for short. I'd like to start by reminding you of something hopefully you've already seen, which is our tree of energy saving opportunity. I want to do this because it will help you to understand how we operate as a business when it comes to delivering you with the insights that you can then turn into energy savings. So it starts with the cliched low-hanging fruit. We describe that as duty cycle optimizations. Effectively, we're looking for all of the examples in your facility of an asset running when it shouldn't be. If you can turn something off, you can save 100% of its energy consumption. So this represents a very valuable component and sometimes underappreciated component of energy saving. Most of us would hope that our facility is running as it should and things are being turned off when they should, but it isn't until we install real-time asset level data that we really understand how big of a problem this is. And I've never been in a facility yet where we haven't found substantial savings with this technique. So we start there, and the beauty is that all of the recommendations that we make in this particular category are free to apply. There's no extra cost involved for you to take those insights and start benefiting from them. We then move up to level 2, which is process and asset optimizations. So within any facility, again, there will almost always be examples of controls or set points that could be optimized, or it could be things like shift schedules, or it could be things like using one piece of equipment instead of another piece of equipment. So there are examples of process optimizations in every business. But again, it's hard to know the value of these optimizations without the real-time data. So at level 2, we will look to expose those to you. Make it clear what is the ideal operating temperature for your facility and is it being met? What is the ideal speed for a fan or a pump within your facility? And we will be able to help you to set that. What is the best piece of equipment to use for a given task or for a given process based upon the hard data that we're capturing? And again, there's no additional cost. All it is the insight, the intelligence to run your facility more efficiently thanks to the data, the high quality data and the insights that we're providing. And the final stage, where there is potentially some additional investment to make, is technological change. And I guess there's two categories to this. One would be our own wireless IoT controls. So if you don't have controls in a particular area of your building or for certain types of asset, we can introduce those for you to help ensure that savings opportunities are realized, to help run these assets more efficiently. And we also have partnerships with providers of complementary technology, things like variable speed drive. So we work with ABB and we can recommend those technologies to you, but those recommendations again are based on data. So we don't just give you a desktop analysis of what you might enjoy in terms of a payback or a return on investment. We actually look at the data and we're able to say, well, this is exactly how that motor-driven application uses energy. So if we apply a variable speed drive in this way, this is exactly how much you'll save and how long it will take to pay back. So we think that's a fairly powerful way of approaching it, and we think that's the right way to deliver value to your particular business. So I'd like to start by making a contrast. So as a user of our Enoscope IoT system, our energy management system, you will get access to our analytics platform. And here's just an example of analytics. I've pulled up a client, a restaurant as it happens, where we're monitoring all of the important things that the client cares about. So you can see here on the right-hand side, we have air conditioning assets individually monitored, frying assets, again, individually monitored, ventilation assets, and heated appliances. Again, all asset level data. And you can also see that we're monitoring the temperature as well. And we can monitor occupancy, and we can monitor humidity, and we can monitor light levels. So we can monitor pretty much anything. Is the door opened or closed? There's a huge amount of data. In fact, on a typical restaurant, we might be monitoring between 100 and 1,000 different things that we're pulling into our platform and then making available via this visualization tool. So anything you want to know about your facility is being captured here. This is your single source of truth. But the challenge comes in how to analyze it. How do you turn this data into dollars, we might say, or money, which is what we care about. Now you can do that here. As an individual, you can log in, you know your site, you can look at the individual applications and you can say, well, that doesn't look right. I need to make a change there, or that doesn't look right. But imagine having to do that every single day for every single asset, for every single building. That is going to take a lot of time. And so what we've sought to do is to automate that, to make it a remote service so that we can do it for you, because we face this challenge as well. So we built a tool specifically designed using AI technology to analyze all of this data automatically and pull out all of the insights that matter to you, the client. So here's a little look at that tool. I guess what I'm doing is I'm giving you a look under the bonnet, so to speak, as to how we deliver our service. So straight away, you can see here we've got an estate that we're looking after. There's about 50 buildings across the UK, and that matters because the climate up here in Scotland is going to be different to the climate down here in the southeast, and that needs to be taken into account. The operating times are different, the schedules are different, the number of assets per restaurant are different. So all of that is being captured, all of that data captured at a very high resolution. I just showed you our analytics platform. And then this tool is pulling that data in and looking to convert it into actionable insights. And what you can see straight away is it's found 160 things just today that are of note, 166 energy saving opportunities with this particular client. And you can also see that it's ranked those in terms of importance. We work with this client, we know what matters to them. And so we've helped to devise a scoring system that works for them. So it's not just alphabetical order, or the time that it happened, it's in order of importance. So this site has a score of 1, which brings it to the top. This is the most important site for us to focus on today. So when our virtual energy manager team log into this tool, that's where they'll start. And then it descends. And you can see here, this site has 39 alerts. The next has 30. The next has 53. The next only has 8, which is a relatively small number. But because they're high value opportunities, it's ranked all the way up in 4th place, because that's where we need to spend our time and attention. Can you see how valuable that is? We're focusing on the things that matter. So as you move down here, the alerts get less and less important until there aren't any alerts, perhaps because the site is now fully operational and fully efficient. So let's log in and have a look at these 166 alerts that we're showing here. So if I open that up, what you can see here looks a little bit like an inbox. So our virtual energy manager logs in and they can see all 166 alerts. And down the left-hand side here, you can see a filter that allows them to focus again on the things that are important. So if I want to, I can filter on, for example, front of house AC. So this is a restaurant, this is where the guests sit, that's important. So we can just click that button and it will show me all of the examples of issues that have been identified with the front of house AC. That's simple. And we're able to do that because we build an energy twin of your facility. We know, based on the energy twin, all of the assets and how they interact and what they should be doing. And that allows us to pull on this data very easily to provide you with the insights that you're looking for. So that's the first thing. The equipment class is all being recorded. And then the next thing is we have these gauges. So these gauges are really where the intelligence is. So we're able to use these gauges to find opportunity within the data. So we said at the beginning, the first level is duty cycle optimizations, things that should be off but are running. So if I click that button there, it's going to show me all of the examples of duty cycle opportunities. If we open up the top one here, it will now pull the data from this particular site. It's an AC in a kitchen, and we can see here straight away what the problem is. It's made very clear to us. We have an operating schedule that says this should be off between midnight and 7 a.m. And we can see here, if you look at that black line, which is the energy use, that it was running overnight. Now, there was nobody in this restaurant and nobody would have known about this had it not been for the real-time asset level monitoring that we installed. And our system has found that because it knows what should be happening on this particular facility and it's documented it for us. So we know there's a problem here. It's used 13.6 kilowatt hours. Doesn't sound like a lot, but again, if you do that every day across multiple assets, across hundreds or thousands of sites, it's a huge amount. So it's really important that we capture all of this waste. That represents nearly 25% of the consumption for that day when it should be off. So it's found that early morning waste, and it's also found some waste here in the evening. It's identified that. And you notice here that it's already decided that this should be escalated to the weekly report, which gets shared with the client. So it already knows that this is important because of what it knows about the client. And it's saying, we need to investigate this. We need to do something about it. So can you see how powerful the ability to monitor the duty cycle is with this particular tool? If we go down here further, we can see all sorts of examples. It's mainly air conditioning. It's mainly air conditioning, but here we have an example of a fresh air extract, energy use when off duty. So let's open that one out. Again, it will pull the data. Again, not quite as much energy, but still 7.9 kilowatt hours. This is just on a single day. And we can see here, it's again using energy overnight. And so our system has found that. And so now we can contact the client, share that with them, escalate it so that they can do something about it. So a very useful way, very simple way. And again, would you know this if it wasn't for a system like this that's monitoring it for you? Unlikely. So that's at the base level, the low-hanging fruit. Let's go up a level. We said level 2 is where we're looking at the asset and process optimizations. So let's open up our versus profile gauge. And what this will show us now is all of the examples, and you can see there are quite a few here, where the energy consumption is diverging from what is expected at this particular site. So you can see here, it's picked up the biggest divergences, which are often at the main incoming supply, which we always monitor. But if you scroll down here, you'll probably find some diverges from elsewhere. So here's one, a center island. So this is in a kitchen unit. And we can see here, excess consumption over profile, 16 kilowatt hours, a 30% increase. Now again, I know we're talking about a restaurant here, but think in terms of principles. What would happen if one of your big energy consuming assets was to suddenly consume 30% more energy than it should? And what impact would that have over a week, a month, a year if you weren't to spot it? So here our system has found this issue. So we can see here, it's a big issue because it's happening throughout most of the day. I can take this 1 minute resolution and I can drop it to 30 minutes, which makes it easier for me to compare. And what I'm doing here is, or what the system is doing is, it's looking at the profile for this asset, which is built up over time. It knows how much energy was used on this particular day for the last 4 weeks. And it's built up, that's what this gray is in the background, it's built up this profile of understanding of how this asset should use energy. So as long as it continues to use energy in that way, there'll be no alert. But you can see on this particular asset, something has happened. Something's gone wrong, or there's been some kind of issue, and the energy consumption has increased by 30% on this particular asset. Again, would you know about this if it wasn't for asset level data and a system like the virtual energy management tool that's monitoring it for you and looking for these types of opportunity? So we can now share this with the client, and there'll be some setting, a temperature setting perhaps, or a control setting on this piece of equipment, this center island, that we'll be able to adjust to bring this back down to how it was before, using energy in the right way. But the minute it happens again, our system will alert us to it. It's constantly working in the background. This is an energy manager that never sleeps. It's always looking for opportunities. We mentioned earlier about temperature. So if I go into the gauge that measures temperature, now it's showing me all of the examples of temperature which is out of range. And again, this is both an energy consuming problem, because if you're overcooling or overheating, you're going to use more energy, but it's also a guest management problem. So if you're underheating or undercooling, that could be an issue. So we are not here just to save energy. We are here to deliver a good quality experience for the occupants, be they staff or be they guests or customers. We need to make sure that we work within the appropriate window for your client. So if you look here on this temperature profile, we can see here in this particular example, let's go to a restaurant. So this is where the clients are sitting. So that matters to the client in particular, how their customers feel. And they've set a temperature window of between 19 and 29 degrees. And what we can see here is the temperature is not within the operating parameter. In fact, in this instance, it's dropping below the requirement. So they're overcooling this particular facility. And potentially, I don't know how you feel, walking into a restaurant that's freezing cold. In fact, look at here, it's dropped all the way down to 16 degrees in the restaurant. And this could be an issue. So if someone in the kitchen is deciding what to set the temperature as, they're hot, they're next to the fryer or the cooker, they're feeling the heat, so they adjust the temperature. But what about the guest in the restaurant? Are they getting the experience they deserve? Well, what our system has done is it's found that there's an issue here. And again, we can share that with the client. You can see DataBot has found it and has escalated it already, but we can share that with the client and they can make the appropriate adjustments to this particular asset to make sure it doesn't happen again and the guest experience is maintained. And this will, of course, save energy because we're not overcooling. We're not using more energy than we need to in order to hit the requirement for the particular client. Just one other example to show you here. If we go into usage after warm-up, what this will do is it will look for any asset that is running idle for longer than it should. So we see here only one example, but this is only one day, but it has found it amongst all of, it must be monitoring, I don't know, 500 fryers, maybe more, and it's found the one fryer that was running idle when it shouldn't be. And it was only a 19-minute idle time. But to show you the precision of the system, it found it. And again, think about this when you apply it to a bigger piece of equipment, a printing press or some kind of large piece of kit that's involved in a manufacturing process. Is it running idle for long periods of time and you don't know about it? Because again, without asset level data, how could you know? Our system will find that for you, we'll share it, and we'll enable you to do something about it. Just one other example, we mentioned speed control. I happen to know, if I open this up, turn that one off, that we've got an example here of a fan. Again, excess consumption over profile. Our system knows how much energy this particular asset should be using. You can see here, this little green line is the average energy consumption for this asset, and all of a sudden, it's using more energy than it should for the period. So it's highlighting that to us. That's a huge increase, 132% increase. It's on the fresh air fan, but it's been picked up and now we can do something about it. We can adjust the speed so it matches the requirement for this particular client. So very powerful. You've seen they're both level 1 and level 2 savings opportunities, again, with the benefit of this tool. And with this, of course, we can then create our duty cycle report. So if I take you here to an example of that, so here's an example of a client with the duty cycle report. This is all of the time that we identified their assets running when they shouldn't be. And you can see there an annual wastage of nearly £25,000. This was already in excess, well in excess of the guarantee that we offered the client. So the system that we put in cost £10,000. The value of the data that we were able to provide was worth to them annually £24,792. They can now take this information. This is a much bigger report, of course. They can take this information and they can go and implement at no cost to them all of the recommendations that we've made so that they eliminate all the duty cycle waste. And of course, what we're also doing is we are monitoring the system in real time. So once we start to get more and more aware of your facility and how you operate, we can set up real-time alarms. So we're not just picking up the data the day after, we're picking it up in real time. You can see here, this alarm was triggered at 6:47 in the morning. I happen to know this asset, it shouldn't be on before 9 a.m. That's the situation. Again, they've got local controls. So someone has changed the control or done something to fiddle with the AC system. We've set the threshold at 500 watts. So anything over that, the client wants to know about it. This was 2.972 kilowatts. So we've made the client aware. We've given them a link to analytics so they can log in and see exactly what happened and when and what's going on. And you can see here then the alarm has been recovered. So what is it? 13 minutes later at 7 a.m. on the same day, the alarm has been recovered, which means we're back below the threshold that we've set for the client. We can set that for any energy parameter, any parameter full stop, for any asset, for any building, and we can provide you with that information so that you can do something quickly. You're not having to wait till the end of the day or the end of the week to take action. Once we have profiled your assets and we understand them, we can start to develop these smart alerting and alarming systems so you can put a stop to that energy waste immediately. Now, we've talked about level 1 and level 2. Now it'd be appropriate to move on to level 3, the final pickings as we mentioned. And so here I'm going to show you an example. Again, it's from the same client, and this is our energy saving reporting component of the virtual energy manager tool. So you can see here we're listing out all of the results that we're delivering for this particular client. It's worthy of note here that we're measuring two important factors. One is what we call raw saving. So that's the difference between what they used before and what they're using now, just a raw calculation. But we're also doing something called normalized saving. So the fact is, if you have less customers, you will use less energy. If the weather is colder, you will use less cooling. If you have less production, you will switch on your machines for less, or the machines won't run as long. That's normal. So what we do is we bring that data into our platform. We ingest that data. For this client, what matters is sales, transactions, and weather. Those are the independent variables that drive energy consumption. And then we normalize. What that means is we remove those independent variables, the weather factor, the occupancy factor, the transaction or the sales factor, to give a truer insight into what the savings will be. And sometimes that means, in the case of this example, the client, third client down, we have a 23% raw saving, but in actual fact, that's more like saving 26% of their energy. Because when we normalize for those other independent variables, actually we've done better than that. But by the same token, if you drop down here to this site, we're saving 42% of their energy, but really that represents a true saving of 14%. So something else is happening to drive the raw savings. Maybe they closed early, or an asset broke, or there were less transactions for some reason. And so we factor all of that in, and that allows us to give you, the client, a much more accurate understanding of exactly what you're saving. And we break that down into its individual components as well, because uniquely we're doing asset level monitoring. This is savings at the building level, but we do asset level monitoring. So we can break that down. If I pick out one of those sites, you can see here we're saving the site 24% of their energy, which is a great saving, nearly a quarter of their energy. The payback there is 0.4 years, phenomenal payback. But how are we doing that? Well, we can break that down. Here's the air conditioning. So remember, we're talking about level 3 now. We installed retrofit IoT devices to control their air conditioning. And you can see the difference. The gray is the before, the baseline. The green is after. That's now that we're in control. So you can see we've stopped using energy overnight. We've reduced the amount of peak energy being used early in the morning. They still have to use energy, but they're using a lot less. In fact, they're using 60% less energy on this particular asset. And we can see clearly what is being delivered. Can you do that with the other investments that you're making? Can you see in real time how they're performing? It's quite powerful. Let's go to the fryers. Again, we are stopping the fryers from coming on early. So we're starting them later in the day. That gives a little peak in the morning, but then we're managing them through the day. And that represents a normalized saving of 5%. Now you might think, well, 5%, that doesn't sound like a lot, but look at how much the fryer category is using in this facility. Over a third of the energy is being used by fryers. So a 5% saving on a third of the energy is actually very good. So again, the asset level data is helping us, but here we have installed a piece of equipment that's helping to ensure fryers don't get switched on early and they only get used when they should throughout the day. Let's have a look at another one. Here's the ventilation. Great example of saving. So previously, ventilation was running overnight. Nobody knew because nobody's looking at this. This is the asset level data. And of course, they could use behavior change and get people to turn it on and off, but they wanted some controls. So we installed some controls. Now the asset comes on at 9 o'clock when it should. It's not running overnight. And then we use speed control to turn the asset up over lunchtime to give it more power so it can draw more out of the restaurant. This is a cooker hood over a bank of fryers. And then as it gets quieter, we drop the speed down. And then as it comes up to dinner time, we speed it up again, and then we drop it down. So we're using intelligence to intelligently control this asset, and we're saving here 53%. Great quality savings being delivered there. Again, go to the heated appliances. What are we doing here? Again, we're starting it a bit later. We're using less during the day with our controls. And so add all of that together, and you end up where you're saving on the main incomer, as we saw earlier, 24% of the energy. And if I want to dig in on exactly what's happening here, I can easily just click this button and it will open up the same analytics platform that I showed you earlier. And I can, if I want to, this particular client doesn't want to, they're not interested so much in the raw energy data, but it's there. If you want it, it's loading up now all of the energy data for this particular asset category. So the AC for the counter, the kitchen, the restaurant, and the staff, all being captured here. And I can look at what's going on, and I can make a decision on whether what I'm seeing here represents what I want to see. Going back to the report tool though, if I look down here, I can see that all of my assets are operating within the assigned duty schedule. So this site is tightly controlled, and that is what the third level gives you. If you don't want to leave it to chance that assets operate within their schedules, then you can install equipment like this to make sure that it is always doing what it should be doing. And then all of the assets are within the temperature controls. Again, we've got tight controls here delivering what the client needs. It's got some further information here around how they're using that energy. The only issue with this client is the daily consumption is a bit higher than expected on their fryers. The chip fryer here, restaurant AC used a bit more energy than expected. And if I want to, I can dial in on that and find out why that's happened. So again, very powerful way at looking at the data and demonstrating that controls, retrofit controls, that technological change can deliver very substantial savings. I can't promise you 24% of your facility, but there it is, 24% savings on this particular building. And that's what's up for grabs potentially, and a phenomenal 0.4 year return on investment. But of course, how am I calculating this saving? Well, I'm using special tools to normalize, as I said earlier, to normalize saving. I'll show you that now. So for this particular site, we've actually pulled in all of the revenue data from January 2022 all the way through to July 2023. When I say revenue data, I mean the main incoming data. So they are being supplied by an energy supplier who will measure normally on a half-hour basis how much energy has been used. We ingest that data, and the more data, the better. And what that allows us to do is to build a model that helps us to understand how this site uses energy. So you can see here, if I take away the baseline, which is what was used during that period, sat behind there is a model. And that model is built on what we know about the site, how it uses energy. Also, you can see here, we've got sales data, we've got cooling degree data, and we build a model that is very closely fitted to the actual consumption of this particular site. So we now know how this site uses energy. We can explain how a change in transaction or a change in weather or a change in occupancy affects energy consumption. That gives us confidence that when we go to make the changes, that we'll be able to report the difference between the two. And that's what you can see here. That's where the 24% savings are coming from. So if I remove the model here, so that is the energy that was consumed once we got control of this site. So you can see there the actual energy consumption versus what they would have used, which is here, had we not been in control. How do we know what they would have used? Because we built this model based on, what is that? 22, 23, 18 months worth of data, 18 months worth of understanding of exactly how this site uses energy. So we have a high degree of confidence that when we say we're saving 24%, we really are saving 24%. We do have the raw data, that you can see that down here. So you can see the difference just in raw data. But in terms of actual energy savings, you can see how powerful this platform is. And this, again, is all automatically generated by our tool. And this is how we can do it so efficiently, so cost effectively for our clients.